Hi everyone, and welcome to another episode of Mr. Carlson's Lab. Let's get started. Quite often I get the question, Paul, would you mind going through this radio that I've purchased? I've been looking for a radio like this for a very long time, and I finally found one that's been restored. Would you mind going through it and just checking it over to make sure that it has been restored properly? If it hasn't, can you address any issues that may have been left behind? Or, address the whole thing if it hasn't been restored. And that's what we're going to do in this video. We're just going to basically look at this radio. We're going to see what's been done to it because supposedly the previous person has restored it. And we'll talk a little bit about the things that should be done and a little bit about the things that may not have been done. Again, we're going to discover all of this together. This thing might be beautifully restored inside. I don't really have any idea. So I was going to do this off camera, just take a look at the radio and see what needs to be addressed. But I figure, hey, maybe I can share some tips and pointers with all of you, and maybe you can use this towards your next restoration yourself. So grab yourself your favorite beverage. I've got mine right here. And let's analyze this radio and see how well it performs. So what I'll do is I'm going to get the thing plugged in, and I'm going to loosely couple my external antenna to this, because there is no external antenna connection to this. And we'll see if the thing receives to start, and we'll go from there. The radio is attached to my isolation transformer and current limited variac supply because I really don't know what I'm up against here. So what I'll do is I'll turn this on and see what happens. So I don't have any external antenna attached. This is just the antenna in the radio. So the antenna that's on the back portion. We'll see what happens. Well, there's noise. Alright, so scan the band. So before I do this, this area is pretty much an RF dead zone. So if this thing is receiving stations in here, it's doing all right. If it receives nothing, well, that's to be questioned at that point. It's got static, so it sounds like it's trying. You can hear that? There's a station there. There's a little bit of a station there. It's trying. It's a good sign. Alright, so what I'll do is I'll just put this about mid-band. We'll start there again. So what I'll do is I'll take that 369 antenna that I just built and grab that same inductor that I used. And clip this on here. Put this close to the back portion of the radio.
From this suit. Correction. New diet, you will do whatever it takes. No matter how many times it takes. Gate Sunday the 3rd. Oh, they can look at this. What happened when you got exercise, stress management, and more. Force radio. Get out the front.
So that's just from holding this inductor close to the antenna.
They haven't decided on the city yet. Down to 3. We've got
I try.
Are you in the person in the
Fundamentally.
You're anti-intellect. Breeze. Why? Cold lefty.
So the antenna is coupling in quite well, and the radio is working not too bad at all. I noticed that the upper portion of the dial isn't receiving a whole lot right now, so that could just be conditions or, could be a multitude of different things, but all in all, the radio receiver itself is performing very well. The fact that it can even hear radio stations in here with, without the coupling to the external antenna is pretty fantastic. just the way it is. So I would imagine something has probably been done to that just for that fact alone. So what I'll do is I will unplug this here, set this forward. The radio itself the bakelite is in very nice condition. So somebody has done some dial gluing here. I'll just zoom in on this. So somebody has done some dial gluing in here and glued the dial in. I don't know how incredibly straight they got that. Doesn't look like it, but it probably can be chipped away and cleaned up. Yeah, it does. It looks like it's kind of a glue that really hasn't taken all that well, so that's kind of a nice thing because that can be cleaned up and maybe this dial can be cleaned up and straightened out a little bit. The bakelite itself looks like this after a while. It usually discolors. There's so many ways to make this look good. You can put a little bit of car wax on there, some car polish. Sometimes some orange and lemon wood finishes seem to work very good on this as well. If you rub them in and dry them off, it makes these things look like brand spanking new again. So for a period of time, and there's a whole sort, or all sorts of other ways of making these things look good. If you're interested in something that's very, very permanent, and cleaning the thing off completely, making sure the bakelite is nice and dry, and putting a clear coat on it, a lot of the times makes these things look absolutely gorgeous too. So there's a lot of different ways of doing things. As many of you know, I'm working on the new lab. So this is one of them here, and then I'm working on another one that's a very large one, and we'll go over some cabinetry and bakelite stuff out there as well. So coating these things with special paints to make them look very good, something that'll last for a long period of time. The knobs themselves look like they're in very nice condition, so no problems there. I've noticed the plug itself, somebody has taken the time to put a polarized plug on this, which is nice. So this looks like some early form of lamp style plug or something like that. I do notice that there is some heat shrink tubing on here, and it looks like somebody has glued a cardboard piece onto this. So they've actually taken, this looks like the backing to a paper pad is what it does. Normally the little cardboard piece that fits on here is, has a shellac or a varnish on it, and it is somewhat of a flame-proof design. But this is just a standard cardboard that they've put on there, so something that could be taken off and improved. It's nice that this is on here. This comes with a few catches, putting the polarized plug on here, and I'll talk about that here in just a little bit. So already a few things that could be addressed with the case. The backside looks very nice. This looks almost spotless. So very, very nice. Very, very nice back or cardboard back on this. The screws on the bottom, everything looks original. I don't know what this is. Probably there was a schematic or something here at one time, which is missing. So the schematic for this model is relatively easy to find. And this is the Series 1. They made a Series 1 and I believe a Series 2. So this is the Series number 1 here. So I'm not going to take the back off because you don't need to take the back off of this. Usually what you do is you just pull the knobs off the front and take the screws out of the bottom and the whole chassis will come out. And we'll do that here in just a moment. Okay, let's take a look inside and see what's been done. So the first things that we need to do here is just take the two knobs off. And we'll remove the screws on the cabinet, which is only 3 of them. They look original, so which is a really good sign. So a lot of the times you see, self-tapping machine screws thread in here, and you see all sorts of things. I've seen it all. So okay, so this one here should probably allow the radio to pretty much come out, as I can feel it trying to slide backwards. Now these radios are kind of interesting because they've got this top and the cabinet won't slide straight out, so you have to tip it because it gets caught on this. So hopefully I can get this all in here. Let's put this here. So that's as far as it'll come. You can see how this is hitting this one point here. So what has to be done is the chassis has to be tipped forward like this and then brought out like so. So let's take a look inside here. It's looking pretty good. You can see that nice and clean up there. So it looks like you can carry these things. See, there's like a vent hole up here. It looks like you can almost carry this around like so, but I imagine that would be kind of a dangerous thing to do because Bakelite is a little bit fragile by now. It looks like they also intended this possibly to be replaced. So if you broke it by carrying it or something like that, you probably take these out and maybe replace this one piece. Did Bakelite just become Breaklite? That was interesting. Okay, let's move this over like so. Well, immediately I see some kind of interesting stuff going on here just on the top. So it looks like they've added somewhat of a tube retainer, and they've soldered this on here to hold the tubes in place. This looks like a shield that's been added. And another one that's been added over here. So this one here looks like it could be factory. They've added this retainer over here and another retainer over here. These little retainers are very common for the early radios from Japan. They had these in them to hold the tubes in place. But this looks like this might actually just be a bent piece of wire or something like that. I don't know. It's kind of neat and would hold it in place for travel or something like that. If this was to be, shipped or something like that, the tubes wouldn't fall out. Why this is soldered to the chassis over here, maybe there's some form of an oscillation issue or something like that. See, a wire has been replaced down here. And yeah, so let's take a look at the speaker. The speaker looks flawless. So that's very nice. The spring, gotta be careful with this back here. I'm just gonna hold this like so. So this spring that holds the dial string tight, there's pretty much no tension on that. So what that tells me is the dial string has probably stretched over time just a little bit. And sometimes that can be fixed up by just moving this up a little bit. And that'll put spring tension back on this because you can see there's pretty much nothing there. So sooner or later there's going to be dial slippage. So this here should, be pulled out like so. So there's continual tension on it. This is pretty much at its end. It's not stretched. So that can be taken care of at this end right here. So that's something that could be addressed. Pointer's pretty nice. Depending on who's purchased this, sometimes they don't want the actual dial face repainted. So that might just be like that for a reason. The top side of the chassis could be cleaned a little bit nicer, that's for sure. The antenna itself is in very nice condition on the back side. You see that? So, and it's not coming off. It looks like that the original tar-like glue that they use is still holding. So now the truth. That's definitely been worked on. Definitely been worked on here. We'll zoom in on this. So lots of, 47 microfarad capacitors. KMG, I would have to look into this to see whether these are legit United Chemicon style capacitors or not. So usually can be told by the vent stamp. There's a resistor down here that looks like the coating is missing. Let's see here, zoom on into that a little bit. Looks like the coating has gone off of that. So that's a good candidate for a replacement down there. Just a nichrome wire style resistor. There's lots of roundies in here that always need to be checked. I would imagine they have been checked because some resistors have been replaced. See one here and one down there. And you can see all the caps have been replaced. So that's always a good thing. So metal oxide resistor been added here, 220K. 150 ohm resistor, looks like it may have been replaced. A bunch of resistors up here in the corner. So they look pretty nice actually. Lots of roundies. So for all of you that have been watching my channel for a long period of time, let's see what that is there. You'll know that a roundie is like, I guess you could call it like an early style of the Allen Bradley carbon composition style resistor. So basically it's a carbon plug. So these aren't to be confused with carbon film resistors. So this is a carbon composition. There's a carbon plug in the center, and then the leads go into a carbon plug. And what happens is the bodies on the roundies is a porous style of body. And any type of, if this has been in, say, somebody's attic, or if it's been in a moist garage or something like that, these things are very susceptible to moisture ingression. And what happens is the values, they drift. So the newer style, they're squared off on the ends and they have kind of a shiny body. It's the newer Allen Bradley style. They're usually very stable. They have to be subject to a really rough environment to make those move around. Or, the circuitry surrounding has really put a lot of, I guess you could say, stress on the component to make the value move. Okay. Whenever you see resistors capacitors like this, you got to be very careful with these. You don't want to replace these if they're not moving. These capacitors here, a lot of the time, are in RF and oscillator circuits. And if you were to say put a capacitor standard disc like a Z5V or something like that, you would be creating a very drifty radio. It wouldn't stay on frequency. So capacitors like this are very important. This is a mica capacitor. You can use an NP0C0G style capacitor in replacements here, as long as the voltages are correct. But usually these never fail. This type of ceramic, like a ceramic tube style capacitor, they're usually good and they last a very long time. I very rarely see that these fail at all. Now you need to be kind of careful with these in some of the European radios. Some of their resistors look just like this, so they look just like what we normally see over here as a capacitor. They're an actual resistor. I've pointed this out in some of my earlier restoration videos, and if you're up to date watching my restoration videos, you would have seen me point that out. Here's another capacitor down here. Right? Something to always keep in mind. Another capacitor right there. That is not a resistor. That is definitely a capacitor. So the capacitors that have been installed are actually very nice. 275 volt AC rated cap. And it's an X2 rating. So that's not too bad. 250 volt AC. So XY rated capacitors are always good for line bypass. It's a safety thing. So that's another thing that goes to the line cord. Now, a lot of the times when radios like this are restored and you put in a polarized line cord, you'll notice that they break the neutral side. So the hot side of the line cord stays constant, and they actually put the switch in the neutral side. So for safety reasons, I upgrade that. So I'll put an actual absolute value line fuse in here, and I'll rewire this so that the switch breaks the hot side so that the neutral is always closest to the chassis. Because if you break the neutral side, the chassis will elevate. So we'll take a look at this here in a moment. We'll see if this one is like that without me having to ohm out all of the line cord. We'll see if this one is still like that. So that's a modification that I always like to do just to be very, very safe. So I always do that. We can also take a look at some of the resistors in here to see how they've held up over time, to see how far out of tolerance they actually are. So I'll get a little bit of test equipment here and take a look at some of the more fine stuff. All in all, so far, this isn't looking too bad. It's not looking too bad at all. There is some things that I kind of frown on. Get a light in here a little bit closer. I can see what's happened is they've cut some of the tabs and they've just elevated the tab. There's actually nothing holding this, so it's floating in midair. Basically, the tension of the wire is holding this. And they've tack the capacitor to this. So this is very common with a lot of techs. What they'll do is they'll trim a lead off the capacitor and use it as a binding post, but they let it float. So usually what I'll end up doing is I'll install some form of a standoff down here, something to hold that rigid so that this won't move around. The vents of the capacitor are pointing right at the bottom of the radio, so that is okay. You'll see that the factory capacitor here is also pointing right at the bottom of the radio, right? And I don't know if that has an actual vent hole in the bottom. A lot of the times when these things vent, they'll vent from around where the little stamp is. So they have a stamp in the bottom of the capacitor, usually a square or a half moon. And a lot of the times, if anything goes wrong, they'll vent out of those or around the leg itself. So having the vents pointed down, as long as they're not pointing at any type of a flammable surface, is okay. If there is, say it's a wooden radio, a lot of the times in the old wooden radios, what they used to do is you'll find a fibrous sheet on the bottom, and yes, that is a sheet of asbestos. So a lot of the times they would have no bottom, but just that sheet down there. And that is to stop, if any components were to excessively overheat, or if a capacitor was to let go, that, it stops the, the flames from hitting the wood, really. So in a case where there isn't that sheet or there isn't a metal bottom pan, it's always a good idea to point the capacitors towards something metal so that if it does vent, basically anything that does fall is secondary. So what I like to do is I like to point the vent of the capacitor itself at a metal surface, so it will shoot at the metal surface. And usually what that does is there's a secondary effect. So if it shoots at the metal, it has a small amount of time to cool off as it's hitting that before it falls on anything, rather than having this thing just shoot directly onto a wooden surface. Okay, so that's something else to keep in mind that could make your radio just a little bit safer. So that's a KMG series of capacitor. Again, whether these are real KMG series capacitors or whether they are a very good looking counterfeit is yet to be discovered. I will look into that. This capacitor right here is placed across the line when the radio is turned on. This capacitor does not have AC line service ratings, so this needs to be replaced. So we can see the neutral line runs up to this point here, all right, because we have a polarized plug, and this is, of course, the neutral line, assuming that the wiring in the wall of the house that this is plugged into is wired correctly. So this is attached to one end of the carbon track in the volume control here. We can see that it runs to the capacitor, down here to this tube socket lug, from the tube socket lug through this wire back over here to this switch. So when the switch is closed, this capacitor is placed directly across the AC line. This needs to be replaced with an appropriately rated AC line capacitor, and they have the X and Y ratings on them. Those capacitors are designed to fail in a safe manner. This has none of those ratings. This is just a DC rated capacitor. 630 volts DC is what this is. This is a standard poly capacitor. So this capacitor needs to be replaced with an appropriate safety capacitor. The radio is plugged into a standard wall outlet right now, and I'm about to see if they're breaking the hot line or the neutral line. Again, the neutral line should be as close to the chassis as possible, and the hot line should be the line that's broken. There should also be an absolute value fuse installed in that line. There is no absolute value fuse in here, so that is something that I would install. So the neutral line in a radio like this should never be fused, and the hot line should be fused. You never want the neutral line to ever go open in this. Again, the chassis can elevate if that happens. Another thing to keep in mind when radios like this are worked on and testing is done, an isolation transformer is a very good idea. So these are transformerless sets, so there is no isolation from the line to the actual chassis. And in fact, many of these older radios, one portion or one side of the line cord is directly connected to the chassis. It just depends on the design of the radio. A lot of them are connected via a capacitor and a high value resistor as well. So isolation transformers are a safety measure that should be considered when a chassis like this is worked on. So this is where the line cord is coming in here. So the black lead here is attached to the neutral line. So if this is hot, I should get 120, 121, 122 volts out of this. And that's on the switch. So congratulations, previous technician. You did your job right. You broke the hot line. So this is the other side of the switch. It's off. I'll turn the switch on. And there we go. So that's the correct thing to do. Again, an absolute value fuse should be added in a case like this, just in case anything ever goes wrong in the particular radio. It's an extremely light value fuse, and that's just an extra safety precaution that should be considered. Now, a lot of the times people say, well, it's, the tubes are in a series string and they don't really draw all that much current. Yes, the cathode bonding wire and the filament in the tube can act as a somewhat of a fuse, but it's always nice if something goes wrong to save the tubes and have a fuse go instead. Fuses are a lot cheaper than vacuum tubes. Let's check some of the resistance values in here as well. That's one thing that we haven't done yet. So let's check this one here. So this should be 2.2 meg. It's 2.4. Not so bad. Remember, we're not dealing with a semiconductor radio here, so 2.2, 2.4. That's not going to make very much of a difference. A lot of the times, if these have moved that amount in this period of time, they're going to be pretty solid at that point. Understanding the actual functioning of this radio and what resistors are placed where will also tell you over time with experience, yeah, it's absolutely fine in that area. Changing this resistor out would make no difference. Okay. So this is 1 meg ohm here. 1.1, absolutely fine. There's a 47k ohm resistor here. See what this one's rated at. 47.8. No problems. I can see a 5.6 meg ohm resistor under here. Let's see what this one's rated at. Wow, that's pretty close. So again, the technician before did his job. That's looking really good. There's no problems there whatsoever. So I'm imagining the reason that these are in here is because, the other ones have been replaced because they're way out of tolerance. So let's see this one here just for the fun of it. 156, 150, no problems there whatsoever. So most of the time these will not move, they'll just open. So this is a wire wound resistor. So when you see resistors like this, usually they're go or no go. And if the resistance value is a little bit different than what it says, a lot of the times they've just been wound like that. So wire wounds. Another thing to keep in mind is these particular types of resistors cannot be used in RF circuitry whatsoever because these are inductive. So they have a coil of wire in them, so technically it's a coil in here. So if you were to use a resistor like this in an oscillator circuit, the oscillator circuit would not be your friend. So you need to be using resistors that are either carbon composition or carbon film. You can use metal film and metal oxide resistors. They're absolutely fine. So no wire wound resistors in RF or oscillator circuits. Keep that in mind. Just for the fun of it, let's see how well the IF is aligned in this radio receiver. I have my signal generator coupled in to this little inductor down here, and this antenna is just laying on the inductor like this, so I can couple this into the radio receiver loosely. The radio itself is tuned to 1000 AM or very close, or 1 megahertz if you like. And my signal generator is tuned to 1 megahertz as well. So I'll turn on the tone just to show you this on the actual signal generator itself. So that's coming out of the radio, right? So now what we want to do is we want to tune for basically maximum here. So I'll put this under here. And what I want to do is I want to tune for a maximum signal. So I'm going to get rid of the tone so that it makes things more stable here. Okay. Now I want to look for maximum amplitude. And when I get this to maximum amplitude is where the IF will be tuned. So let's find out here. You can see that's going down, right? So you can see the IF is going to shift as we're doing that. Watch the frequency up here. So at maximum amplitude is where it's going to be. And it's right there. So it's very, very close. So it should be 455. That's maximum amplitude. right there. So you have 448, 449 in that area. It's very close. Now, if the IF is off frequency, a lot of the times that will just affect dial tracking. If it's out a little bit, not too big of a deal as long as it's peaked up at that frequency that it's off. So this is very loosely coupled. You'll see that I haven't actually clipped this to this because what it will do is it will drag the alignment off. So there's enough amplitude there that I can just put my probe close to this and it will pick that up. If I was to clip this directly to that, again, it's going to drag the last stage and it's going to cause issues. So I don't want to do that. So not bad. The IF, is relatively close. It could use peaking up at 455 kilohertz. Let's see how well the oscillator in this radio tracks with what's written on the dial here. So they're two completely separate devices. There is no interlock between the two. So when the engineers designed this radio receiver, they put a lot of time into making this oscillator section very accurate so that in a production run, they could always make it align with the dial scale that they've created. Now, there are alignment points inside this radio to make the dial scale calibrate correctly, but that can be affected if some of the components in the oscillator section itself have been replaced. And as you can see, many of those have been replaced. So let's see how well this tracks. Right now, this is pointed at 900 kilohertz, and if you take a look right above here, I'll put a signal generator up here. That signal generator is set to 900 kilohertz. So this is 900 kilohertz right here. It's modulated with a 600 cycle tone at 50% modulation, and the output level is 50 millivolts, and that's just driving this little coil back here, which is loosely coupled to the antenna. So I'll turn up the volume. This is already on. And as you can hear, nothing is there. All right, so I should be hearing a tone right now. So I'll move this up. There's nothing there. There's that tone. So I'll turn this down. It's getting pretty loud. And right there is about center. So as you can see, it's almost one complete bar out. So we should be receiving that tone right here, not down here. So let's see what it is down here. Let's try 600 just for the fun of it. Okay, so I'll go 600 kilohertz. Okay, I'll turn this up. You can hear it anywhere along the dial. So right now we're right at 600 kilohertz. Right about there is center frequency. Right there. So as you can see, we're actually into the other bar here. So that's how far off the alignment is here. Now, if we go to the other end of the dial, we can see whether this has been compressed or whether it's been stretched, and that will give us an idea of where the actual alignment capacitor has been placed. So I'll talk about that a little bit more when we actually get into the alignment itself. There's actually, in many radio receivers, the plates in the capacitor, when the dial doesn't track correctly at all, you can actually move some of the plates around to make it track a lot better as well. Again, in a restoration, we'll talk about that at that point. So let's take a look and see if this is up at 1600 here. So I'll put 1600, 1600 kilohertz in here, or 1.6 megahertz if you like. So let's go right up to the top of the dial.
Shot.
Okay, turn this up. There's nothing there. There's nothing. There's some loud radio stations. So I put this here really close to the antenna. So what's happening is it's actually above. So if I get this right in the right spot, you can hear how it's there. Don't want to overload anything. See that? So it's actually above. So the dial scale has been stretched. So it's down this way and it's up this way. So technically it needs to be compressed. So what that tells us is there's a very good chance that somebody has actually played with the alignment in here, and there's also a very good chance that that's due to somebody changing the components. As I've explained in many of my other videos, many of the oscillator components in these older radios are hand selected. So what they'll do is they'll buy a lot of capacitors. When I say a lot, like a box, a lot of a whole bunch of them. And what they'll do is they'll look for certain values out of that lot in order to make their dial scale track correctly. So a lot of the times when they design these things, sometimes they will work out to, perfect values, but on the production line, they'll find that maybe it's, instead of being 10 picofarad, it's 12.2. That makes it align a little bit better. So what they'll do is they'll have somebody grading components and putting components that will say 10 picofarad on them, but they're actually about 12.2. And that's why I absolutely always tell people, if you're working on an oscillator section in an older radio, one like this that has mica capacitors in them, don't touch them if they work and they're not leaking. And if you read those capacitors a lot of the times, you'll find that their values are a little out from what they say, yet the dial tracks perfectly. And there's your answer with hand selecting components. Now, I've covered this in other videos as well. If you're interested in learning more about this kind of stuff, I have a lot of videos here on YouTube. And of course, I teach an electronics course on Patreon. I talk a lot more about this up there as well. So now this makes me question at this point, right? Every radio and everything tells a story. This makes me question, is the IF section actually aligned in this, or was it left alone? It's off frequency just a little bit, so that might be due to changing components and moving things around in there. It may have received okay, so it was just left alone, so that might still be a factory alignment, and that's the reason it's out just a touch, because this dial scale is miles off. It is miles out. So the only way to really tell that is to look in the tops of those transformers, the IF transformers, and see how well the IF transformers themselves have been treated. A lot of the times you can see if they're heavily screwdrivered, or sometimes they look like they've been completely left alone. So again, every circuit tells a story. So what do you think? Do you think we should go through this and restore it again? You can leave your comments below, and I hope you enjoyed. If you're enjoying my videos, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos like this coming in the near future. We'll be taking a look at vacuum tube and solid state electronic devices alike. So if you haven't subscribed, now would be a good time to do that as well. And if you'd like to be notified as soon as I post a new video, don't forget to tap that bell symbol. If you're interested in taking your electronics knowledge to the next level and learning electronics in a very different and effective way and gaining access to many of my personal electronic inventions and designs, you're definitely going to want to check out my ongoing electronics course on Patreon. I'll put the link just below the video's description under the Show More tab, and I'll also pin the link at the top of the comments section. So if you click on the link, it'll take you right there. All right, until next time, take care. Bye for now.